Hello, mathematicians. Today we're starting Unit 6, which is some new learning for us. So this is all having to do with problem solving. So our learning targets are, we're going to focus on writing situation equations, and we're going to learn what those are. And we're going to do situation equations for all 4 of our operations. Then we're going to practice writing word problems based off of an equation that we're given. And lastly, we're going to talk about determining reasonable answers. So all 3 of these skills are things that you've done before in previous units, but we're going to focus on them now, okay? So a great thing for you to do would be to have a piece of paper with you and to pause the video so that you can do these problems along with me, okay? I'm just trying to get this. All right. So it says, I'm going to point with my pencil so you can see it because I know you don't have this at home. A situation equation shows the structure of information in a problem. A solution equation shows the operation that can be used to solve the problem. Okay? So we have a situation equation, which is what's going on in the problem, the situation. And then we have a solution equation, which then says what the solution of the problem is. So we're going to focus on this top part here. So I'll read you the situation, and you could write down these numbers. I'm going to show cubes, which is circle the numbers, underline the question, box keywords, in order to read this. Last night, 312 people attended the early showing of a theater movie. How many people attended the late showing if the total attendance for both showings was 961 people? So I'm going to box late and people because we're trying to solve for how many people attended the late showing. This model here is something you can draw. Models can help us understand how to solve a problem. So we have 961 total people. That 961 is made up of the 312 people that went to the early showing and this amount of people that went to the late showing that we don't know. So we don't know what this number is, so we put a variable in there in place of it. So we put an n. It's kind of like if you were to put a question mark because you didn't know what it was, but instead we substitute in a letter. So n just means that number that we don't know. All right, first, A says, the number of people who attended the first showing is known because it gives it to us, write the number. So we have 312 people who attended the first showing. Write a situation equation to represent the problem. Use the letter N to represent the unknown number of people. So what we know is that 312 people attended the first showing. Another amount of people attended the late showing, which equals the total of 961 people total that went to the theater. So this is our situation. These people went to the early, these went to the late, this is who went in total, okay? I wrote N because I don't know this number yet. Next, it says, write a solution equation for the problem. So you'll see here that my unknown number was in the middle of my equation. For a solution equation, I'm going to write how I'm actually going to solve it. So I can't literally do 312 plus n, but hopefully you'll see, okay, I can use the inverse operation and take my whole and subtract the part. So my solution equation would be n, or this number, equals the total minus the part that I know. So that's the difference between a situation and a solution equation. The situation equation is what's going on. The solution equation is you solve for what you don't know. So that variable is on the other side of the equal sign. So then we subtract 961 minus 312. I'm using the strategy of stacking to help me. Ooh, sorry, made a mistake. Sometimes when I'm not paying attention, I make mistakes. So 9 minus 3 is 6. So then we have 649 people was our label. So that's who attended the late showing. So if we were then to complete our little triangle up here, this n, we would write 649 because 649 plus 312 equals 961. So if I were to go back up to here to my situation equation, if I plugged in 649 where this n is, then the equation would be completed, okay? We're going to do one on the other page. So it's really just a way to break down problem-solving questions. It's important to break it down into the steps to make sure you don't accidentally miss a step. So here, a car odometer showed 6,437 and 5/10 miles at the end of a road trip. How many miles did the odometer show at the beginning of the road trip if the car was driven 422 and 3/10 miles? So we want to know how many miles it showed at the beginning of the road trip. I'm going to write down my label here. Our directions say, write an equation and use it to solve the problem, okay? So I can write a situation equation and a solution equation in order to do this. It says draw a model if you need to. Well, I'm going to draw, okay, I have 6,437 and 5/10. That's my total. I know that the trip itself was 422 and 3/10 miles. So I want to figure out what was on the odometer, or the amount of miles that the car was driven, before we left for the road trip. So first I'm going to write my situation equation, which is we have our parts, which are what we know plus what we don't know equals our total. Now, I want you to pause and think, how would we then switch this around, thinking of our inverse operation of how to solve this? How do we solve for what we don't know? Our solution equation is then n equals our total minus the part that we have. And that will then give us this unknown part. So when you do that, you can pause the video and you can do that subtraction math in order to solve this, okay? So pause and solve. Hopefully when you subtracted, you got 6,015.2 miles. Or 6,015 and 2/10 miles. I always find it helpful to write my label first so I don't forget it, okay? And let's move on. So that's how you write your equations. First, you write your situation equation, which is how you get to that total. And next, you write with your unknown on one side of the equal sign, and you're writing how you're going to solve it. So you might have read this at first and been like, yeah, Miss G, I know that you have to use subtraction to solve that. But we go through these steps so our brain understands the process, okay? Here, now we're moving into a next part of this, which again isn't super new, it's just a new focus for us, okay? So it says, write equations to solve problems, which is what we just did. Sometimes it is helpful to write a situation equation and a solution equation to solve a problem. Other times, you may only write a solution equation. So sometimes you're not going to need to write both of these like we did here, where here we had 422.3 plus this unknown number equals our total, then we wrote our solution equation. You're not always going to have to do both. So let's see what we need to do for this main problem here. On the first day of soccer practice, 2/5 of the players were wearing new shoes. The team has 20 players. How many players were wearing new shoes? Okay, this is going to help us break it down. Let's look at A. The number of players wearing new shoes is given as a fraction. Write the fraction. Okay, 2/5 of those players were wearing new shoes. The number of players on the whole team is given. Write the number. Okay, we know the total amount of people on the team is 20. Now it's going over what we're being asked to do. It's breaking down the question. It says, you are being asked to find a fraction of, keyword, a whole. Write a solution equation to represent this fact. So we know a solution equation means that our unknown has to be on its own side of the equal sign. So up here, they gave us a letter to use for the unknown. They told us to use n. So I'm going to write n equals in order to start this. If you want to pause and try to write the solution equation on your own, I think that's great. So I saw this key word, fraction of a whole. Of means multiply. Okay? So what I'm finding is 2/5 of the 20 total players. So that's my solution equation. And then, lastly, you solve your equation. You can pause and solve. I rewrote mine here, and I wrote 20 over 1, which means the same thing. Now I'm going to simplify before I multiply. So we found that 8 players out of 20 were wearing new shoes. I'm going to show you how to check your answer. We're saying 8 is our part out of the whole 20. Can we simplify this fraction? You betcha we can. Both of them can be divided by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. So 8 is 2/5 of 20. Awesome. Hopefully you're seeing that this isn't too difficult. It's just turning your problem solving into steps for your brain, okay? Moving on. Let's do... Here we're going to use our math talk to be able to explain why these answers will be reasonable or how we can think about what types of answers we should be getting. So here it says, suppose you were asked to multiply the numbers at the right. So 2,500 times 6/10. Without actually multiplying the numbers, give a reason why an answer of 15,000 is not reasonable. Think right now in your head, how come when I do 2,500 times 6/10, I can't get this number? So, the reason that I can't get it is because when you multiply, I'm going to use some shorthand. When you multiply a whole number by a number less than 1, when you multiply a whole number by a number less than 1, your answer will be smaller than the whole number. So we can't take 2,500 and multiply it by 6/10 and get a bigger number because 6/10 is less than 1. So we're only taking part of that 2,500. We've talked about this a few times on Zoom, so I'm hoping we remember this concept. Now let's work this way. Suppose you were asked to divide the numbers at the right. So 90 divided by 1/3. Without actually dividing the numbers, give a reason why an answer of 30 is not reasonable. Think about why you can't do 90 divided by 1/3 and get 30. So hopefully you remember that when you divide by a fraction, here's a tip: keep, change, flip. So the reason that you can't get 30 is because dividing by a fraction involves multiplying by its inverse, which would actually be 3/1. So you're actually doing 90 times 3/1, which is really just 90 times 3. So in order to do this quicker, my fast fact, 9 times 3 is 27 plus a 0. So these rules go against what you were taught first about multiplication and division. When you multiply by a number less than 1, your answer is smaller. When you divide by a fraction, your answer gets larger. That's because this is asking you to take 90 wholes. So say you have 90 pizzas and you're splitting them all into 3 pieces. And then it's asking you how many total pieces you have. So your number has to get bigger. Moving on. The next thing we're going to talk about is how you would write a multiplication word problem. We've done this a little bit in class and on some of our homeworks where it gives us some sort of situation equation like this and it wants us to solve it. Oh, I'm sorry, I misspoke. This one is a solution equation because we're solving for the unknown. This one here is a situation equation because the unknown is in the middle. So let's see. You could try this on your own and then solve it and see if it makes sense. So it's 3/4 times 2 equals C. I'm going to give you an example of how you can write a multiplication problem that aligns with this equation. So for example, we could say a recipe needs 3/4 cup of flour. The reason that I chose flour in a recipe is because when I'm thinking about fractions, a lot of times my mind goes to baking. So a recipe calls for 3/4 cup of flours. To make 2 times, or to double the recipe, in order to make 2 times as many servings, or as much, how many cups of flour are needed? And I ran out of lines a little bit. So I said, okay, I have 3/4 cup of flour, but I need to multiply it by 2 because I'm making 2 times as much. So say I'm making a pan of brownies. I don't want to just make 1 pan of brownies, I want to make 2. So I need to take what I need and multiply it by 2. And then what we're solving for is how many, oh, I wrote any, silly me, how many cups of flour are needed. So now let's solve it. 3/4 times 2 equals this unknown number. It says draw a model to show the situation and then solve the word problem. So a way that we could draw a model is we could use a number line. We have 0, 1, and 2. We're talking about measuring things in fourths. So I'm going to split my number line into fourths. So here we have 1/4, 2/4, 3/4, and 4/4, or 1 whole, okay? So first we're taking 3/4, so I'm going to mark all the way to 3/4, and we have to double it, so we need another 3/4. So now I actually have 1, 2, 3, 4, 5, 6/4, which is an improper fraction, 4 goes into 6 once, and I have 2/4 left over. Simplify 2/4 by dividing by 2, and we get 1 1/2. So 1½ cups are needed. You could have also done that by just doing 3/4 times 2/1. And then you would have gotten this 6/4. And then we put it in our final form here. So drawing a model can help your brain. It doesn't have to be super sophisticated. All I did was draw a number line and circle 3/4 twice. Okay? Let's move on. Okay. The last skill that we are going to talk about is determining if our answer is reasonable, which is kind of what we just talked about when we talked about what happens when you multiply by a decimal or divide by a fraction. So let's talk about our first skill. It says using rounding to determine reasonableness. Okay. Altogether, 91,000. Sorry, my dog is eating. Sophie, what are you doing? No, get out of there. Sorry, my dog was eating something. Altogether, 91,292 people live in Waterloo and Muscatine, 2 cities in Iowa. Doesn't really matter where the cities are, we just need the amount of people. The population of Waterloo is 68,406 people. What is the population of Muscatine? So we're solving for the population. So we want to have an equation and an answer. So I'm going to write a solution equation. I'm going to take my total amount of people, 91,292, subtract the part that I know, 68,406, and that's going to equal what I don't know. I'm going to write it as M because I'm solving for how many people are in this city of Muscatine. When it says write an equation, you have to write the equation first. An equation has an equal sign. Then it wants you to write your answer. So you can pause and solve. And it equals 22,886. We need a label. The population is measuring people. Now it wants us to estimate to say how we know that our answer is reasonable. So I'm looking at 91,000 and 68,000. And I'm going to round that to the nearest, I'm going to round that to the nearest 10,000 in order to help myself. So I'm going to say 91,000 is about 90,000 because it's closer to 90,000 than it is to 100,000. And I'm going to round 68,406 people. That's closer to 70,000 than it is to 60,000. So it's about 90,000 plus 70,000, which if you use your fast fact strategy, 9 plus 7, oh, I'm sorry. I'm supposed to be doing subtraction. That was my bad. 9 minus 7 is 2, and then we add the zeros we ignored. So our estimated answer is 20,000, and we got 22,000, which means our answer was reasonable because it was close to our estimation. That's how we can use rounding to determine if our answer is reasonable. All right. Here it says use estimation and mental math to determine reasonableness. In a school gymnasium, 588 students were seated for an assembly in 21 equal rows. What number of students were seated in each row? Okay. I'm boxing equal. So we're talking about the number of students were seated in each row. So it's talking about equal rows, and we want to know each row. So my mind immediately went, ooh, I need to divide those number of students into those equal rows. So first, my equation and my answer. So I'm going to divide those students, 588, into 21 equal rows. And then I'm going to get the number of students. I'm going to use n for number. You have to write your equation. Then I'm going to solve. pause and solve 588 divided by 21. Okay, you should have gotten that the unknown was 28 students. 28 students were in each row. If you wanted to check your answer, you could do 28 times 21 in order to get 588. So the way we'll use estimation in mental math is we'll say, okay, 588, if I'm rounding that to the nearest hundred, that's basically 600. And if I'm rounding 21, 21 is a very, very close to 20. So that's how I estimated. And then my fast fact would be, okay, I know that if I divide, 6 divided by 2 is 3, and then I have to add my 0, okay. Or I could have said, well, I got 21 as my divisor, which is about 20, and I have 28 as my answer. That's about 30. 20 times 30 is 600. Well, 600 is really close to 588. So those are two ways you can use estimation in mental math in order to see if your answer is reasonable. Let's move on to our last part here. So here, it says use benchmark fractions to determine reasonableness. Benchmark fractions would be 0, 1/2, or 1 whole. It says write an equation and use it to solve the problem. When possible, express your answer with a whole or mixed number, so it does not want improper fractions. Use benchmark fractions to verify or to show that your answer is reasonable. A 5/8 inch thick paperback book is placed on top of a 15/16 inch thick paperback book. So here I'm going to draw a little picture. They're basically stacking books like this. Okay? What is the total thickness of the book? And we're measuring it in inches, so I've boxed inches. Okay, so let's write our equation. We have 5/8 inches, and we're adding it to 15/16 because we've stacked these books together and we want to know the total thickness. And that equals, I'm going to put n again, that equals the total amount that we don't know yet. So there's our solution equation because we're not sure what n is yet or what our total is yet. So you can pause and solve 5/8 plus 15/16. Go ahead. So once you've added it, you should have gotten 1 and 9/16. We're measuring thickness in inches. So now it wants us to use benchmark fractions to determine our reasonableness. So I'm going to look at 5/8 and 15/16. I'm going to think, is 5/8 closer to 0, 1/2, or 1? Well, 1/2 of 8 is 4, and it's only 1 away, so 5/8 is close to 1/2. 15/16 is only 1 away from being 1 whole. So that's very close to being 1. So that's how I would use those benchmark fractions. And I would say, okay, 1/2 plus 1 whole equals 1 and 1/2. Let's compare this to the actual answer we got. 1 and 9/16. Well, 1/2 of 16 is 8, and this is only 1 more than 8. So 1 and 9/16 is very, very close to 1 and 1/2. So that's how we would use benchmark fractions in order to determine if our answer was reasonable or not. All right. Last one. Predict to check for reasonableness. So here it says, 4 runners competed in a 10-kilometer relay race. Each runner ran the same distance. What is that distance? So they ran the same distance. What is that distance? Okay, when it's a relay race, that means they work together in order to run the whole amount. So we had 10 whole kilometers, and we're dividing it equally, because they ran the same distance, amongst the 4 runners, and that equals the distance that they ran that we don't know yet. Here's our solution equation. 10 divided by 4, pause and solve for 10 divided by 4. So for those of you that might be a little confused, you could do 10 divided by 4 like this, or you could do 10 divided by 4 like an improper fraction. 4 goes into 10 2 times, which gives us 8. 10 minus 8 is 2. 2 and 2/4. Hopefully you know that 2/4 simplified is 1/2. So each runner ran 2.5. Our relay was measured in kilometers. Kilometers shortened is km. Now it says, use mental math to identify 2 whole numbers that your answer should be between. Okay, let's think. 2.5, well, our answer, that means that this answer is between 2 and 3. Can you think of fast facts that will tell you why your answer needs to be between 2 and 3? Well, let's see. 10 is between the numbers 8 and 12, right? Would you agree? 10 is between the numbers 8 and 12. Well, if we do 8 divided by 4, we get 2. And if we do 12 divided by 4, we get 3. So if we did 8, we would get 2. If we did 12, we would get 3. 10 is in between those two numbers, and we got 2.5. So that means that our answer is reasonable, because 8 divided by 4 is 2. 12 divided by 4 is 3. So 10 divided by 4 has to be right in between that. Okay, so using your newfound ability to write situation equations and solution equations, remember, a solution equation has the letter of the thing that you don't know yet on its own side of the equal sign, okay? And then the operation that you're using to solve it. And how to check your answers for reasonableness, use your understanding of that, and remember to use some models and complete the assignments and the work for the week. Great job.